And here I'm briefly going to have a look at an exercise in calculating the paired t value. So in the last exercise we looked at calculating the t-test for independent samples, and this is for dependent samples. So I'm going to start this example in Excel, and I'm going to leave this example for you to complete yourselves. So here in front of us is the street. So this is the workbook. The exercise is a set of data from telecoms providers. So you can see here that you've got a telecoms provider, Verizon, and they provide both TV and internet. And then Suddenlink provides TV and internet. So we've got every provider provides two services, TV and internet. And there's a score there in columns E and F, which is some sort of satisfaction rating. So we want to know, are the two related? Is there no difference between the satisfaction for internet and the satisfaction for TV? So you can see, for instance, for Verizon, the score is about the same for TV and internet, but then for RCN, the score is markedly better for internet than for TV. So this is the pair t-test because this data item 74 is not independent of the previous, it's connected to that. Those two pairs, those two go together. So what we have to do is calculate it using the pair t-test formula. And so to get the t-score, which we're going to put into cell B13, we need to get the average of the differences. So we get all the differences for all of these, and then get the average. And we get the difference between that average and the hypothetical average, the hypothesized mean difference. So the hypothesized mean difference is 0. We're saying our null hypothesis is that they are the same, so our hypothesized mean difference is 0. And then underneath this is the whole thing underneath the horizontal line, that is the whole denominator, is the standard error. So we want to calculate that's the standard error, is what goes underneath the line, and that is basically the standard deviation of the differences. We got the mean of the differences, the standard deviation of differences divided by the square root of the number of items. So if we look so I'll start this and I'll let you finish it yourselves. So the hypothesized mean differences is 0. The level significance we've decided we want is 0.05. This is the common one. So we want to be 5%. We want to get a 5% significance level. The sample size is equal to count of these. Um, yeah, it's sample size. And if you look at when you look at the model solution, you'll see that they took the whole of column E because they set up the spreadsheet so that you could add in new data, which would be larger. So the mean difference is the difference between the first and the second. And that's the actual differences for each pair, and the mean difference is the mean of that. Okay. Now, right, so that's the mean difference. The degrees of freedom is just the count minus 1, so it's sample size minus 1. The standard deviation is the standard deviation of these figures. And the standard error is just the standard deviation divided by root n. Right? So that's easy. Then the sample statistic is just this t calculation. You put that in there. So the t calculation goes in here once you've calculated these other elements. So that t statistic will be the mean difference xd minus that divided by brackets the standard deviation. Sorry, the standard error divided by the standard error. That's everything underneath the line. So that'll give your t statistic. And normally what we did in the very first exercise, you take that t statistic and read it up against the t table, and you get your p-value. But what we can do is you can get a p-value directly here. So we can use the formula. And that's the exact same formula, so I'm not going to do it in detail here because that formula in cell B18 is the same formula that was used in the previous Excel spreadsheet that you already have. So it's a t-distribution formula, and it's two-tailed. So there is a one-tailed version as well, and it's the t-statistic. Now what they do is to put absolute in here to make sure you don't get a negative figure, because the t-statistic can be a minus figure because internet's lower and higher than TV, and all you want for this is the absolute value. So two-tailed, and I'm going to make that a bit tidier. No, sorry. So you can see the example there, and it comes up. So there it is. Uh, X is the t value here, and that you want it as an absolute value. And the degrees of freedom is simple. That's already calculated. So that'll work out once the other figures are available. So it's just an error. Too many brackets. So that'll work out once you get your thing. And the upper critical values, that's just the inverse of 2t. So it's reading the table backwards. We did that before. So if I want to do that one there, it'll be this formula here. So t the inverse, so returns two-tailed inverse of the student's teacher distribution. So that's it. And the probability is just the alpha value, and the degrees of freedom is just that. Okay. So that's easy. So you can have a look at that. So effectively, this bit here is the same as in the previous calculation. The difference is in the earlier parts. So just complete that whole table, and you should be able to get that answer then from this table yourself. Okay, thank you very much. That's that exercise completed.